All right, so for question number 5, we're going to look at a limit. And we're going to look at the limit as we approach the point in the xy plane at the origin. And we're going to look at x squared minus 3x squared y plus y squared. Plus y squared over 4x squared plus 4y squared. Now I'm going to rearrange this so that we can get some things out of the way. So first I'm going to pull out a 4 from the denominator. So I'm going to have 1/4 times the limit as we approach the point 0, 0 in the xy plane of x squared. I'm going to do some rearranging up here. Plus y squared minus 3x squared y over x squared plus y squared. And I'm going to break this fraction apart. So I'm going to have the limit as xy approaches the origin on the xy plane of x squared plus y squared over x squared plus y squared minus 3 times the limit as xy approaches the point 0, 0 of x squared y over x squared plus y squared. So I've used my limit laws to break this apart. Oops, and the 1/4 is times all of this. And I'm going to be able to see that this is 1. And so our big job here is to find this limit of x squared y over x squared plus y squared. And so what I'm going to do is I'm going to approach what y equals 0 wherever x does not equal 0. And notice that no matter if I come down the line y equals 0, so if I come across the x-axis, all this is always 0. And so around the seam of the x-axis, this is 0. Around the seam of the y-axis, this is also 0. And so what we want to do then is we're going to say that the limit of xy 0 of x squared y over x squared plus y squared, so this function, is equal to 0. That's going to be our assumption that we'll make after testing a couple paths. And so what we want to do is we want to prove this. So we'll take x squared y over x squared plus y squared minus 0 of the limit, and we'll make it less than some epsilon whenever zero is less than or whoops, we have some delta greater than 0. That's going to be greater than our magnitude of any vector, right? Any x squared plus y squared vector. So we'll take this limiting process and right with the 0 here, I'll rewrite this as x squared plus y squared is less than epsilon. And what we'll note is everything is going to be positive coming out of here except y. So we'll change this to x squared, the absolute value of y, is less than epsilon. And what we want to note here is that we get some, if we look at this part of this here, and we look at this vector itself, no matter what happens with this kind of the magnitude of anything that moves in x and y, since are free, then an x squared will always be less than or equal to x squared plus y squared. Right, when y is 0, these are equal, but for any other parts, this inequality holds. And so with that setting into place and with us using this absolute value here, which this holds whenever this is true, then what we can do is we can look at this side of things. So let's take x squared, absolute value of y, x squared plus y squared downstairs on equality, right? When x squared is equal to x squared y squared, then in this whole thing becomes 1. And so this is less than or equal to the absolute value of y. And we can make a little note here that if I divide x squared, right, less than or equal to 1, it's kind of the idea that we're getting from here, that if we look at the boundaries, we always get something less than or equal to 1. So that means we can take this relationship and these relationships and we can look at when this is less than or equal to y, and we can focus on the equality part, because we can take this absolute value portion and we can write that as y square root of y squared, which is less than or equal to x squared plus y squared. Right, doing a little bit of cross multiplying here and dealing with the x squared on one side and the x squared plus y squared on the other. We were able to trap it like this. So we're going to choose delta then to equal epsilon. And that lets us then say from this inequality up here, all right, we'll rewrite this down here, that we can rewrite our whole initial statement is going to be less than x squared plus y squared, which is less than delta, which is equal to epsilon. And this really creates our definition of the limit. And so we can say that the limit, as our point approaches the origin, of x squared y over x squared plus y squared is equal to 0. So if I come back up to here to the relationship I have, then this becomes 1/4 times 1 minus 0, or the limit we have is 1/4.